Hello guys, so we are back with another video in which we will be discussing our mock test that was held on Friday, I guess 28th of February 2025. We will be discussing every single MCQ in perfect detail and why were we getting low marks besides all those lectures that we had part 1, part 2 and part 3. So let's move on without any further delay to our first MCQ. In a mixture of 7 gram of nitrogen and 8 gram of oxygen, mole fraction of nitrogen is. So basically we had made this test really difficult in order to make stoichiometry perfectly fine for you, because you had many days to prepare it and we were trying our level best to find every single MCQ unique and difficult one. So let's start with this MCQ. You may see that you have a mixture that contains 7 gram of nitrogen and 8 gram of oxygen. In order to find the mole fraction, the perfect formula is mole of that particular substance for which you are finding the mole fraction divided by total number of moles. So this is the perfect formula. For 7 gram of nitrogen, mass in gram divided by molar mass, 7 grams is the mass in gram of nitrogen gas, while molar mass is 14, which makes 1 by 2 moles of nitrogen. I hope you have read it in our lectures and it is really simple for you guys right now. And then comes 8 gram of oxygen, mass in gram 8, molar mass of oxygen 16. This also gives you 1 by 2 moles. So what are the total number of moles? 1 by 2 plus 1 by 2, 0.5 plus 0.5, net number of moles is 1. Mole fraction of nitrogen is to be found, so 0.5 divided by 1, you will get your answer as 0.50. That is delta option. Let's move on towards our next MCQ. A polymer of simplest formula. Okay, this is another MCQ which was not discussed in our lecture, but it might come in your MDCAT, so we had put it in our mock test that was free of cost. So basically, for to solve these equations, you just need to do one thing. कि सबसे पहले write down the molar mass, then divided by mass of empirical formula, whatever that empirical formula is. So what is the molar mass? The question has given us 28,000 grams per mole. 28,000 grams per mole. Okay, and what's the mass of the empirical formula? CH2, carbon 12, hydrogen plus hydrogen 2, 12 plus 2, 14. Dividing this, I can also divide it directly by 14, but you may also do it step by step by dividing with 7 and then 2. It's your choice completely. I am dividing it in one single step because it is too simple. 14 ones are 14, 14 twos are 28, 0, 0, 0. So it is 2000 times more. So the correct answer will be 2000 times that of its empirical formula, that is delta option. Okay, let's move on. What mass of NaOH is present in 0.5 moles of sodium hydroxide? This is basically the first part of our stoichiometry, in which we have discussed the basically formula that is stating moles is equal to mass in gram divided by molar mass. Mass in gram divided by molar mass. So what mass of NaOH? You have to find mass in gram. You have been given with the moles. Molar mass is sodium 23, hydrogen 124 plus 16. Okay, I can write it down over here to 23 for sodium, 16 for oxygen and 1 for hydrogen. 23 plus 1, 24. 24 plus 16, 24 plus 16, that makes 40 grams, I guess. So 40, you will multiply it with 40 and you will get your answer as 20 grams. That's your delta option. Once again, delta, delta and delta is coming in our right answers. Let's move on. Oh, that's a big statement. Iron is manufactured industrially in a blast furnace using hematite and iron ore, an ore of iron and reducing agent carbon monoxide. Okay, the equation is also given. Now let me ask you, what is the molar mass of iron? It is 56. What is the molar mass of iron? It is 56. 5 6 56 plus 3 carbon monoxide forms iron plus 3 carbon dioxide. Okay, the equation balance, we don't need to do anything. Calculate the mass of iron ore used to manufacture 56 gram of iron in excess of carbon monoxide. Okay, this is a part 1 video MCQ that's too easy for us. This is basically saying that you need iron to be 56 grams. You need iron to be 56 grams, and that's the molar mass of iron. So in order to find the moles, it will give you 1 mole. Mass in gram 56, molar mass 56, 56, 56 cancel and give you 1 mole. You have to make 1 mole of iron. Okay, take the ratios now. Take the ratios. It is saying assume the ratio to be 100%. What is it asking you? Basically theoretical yield, part 3 of our video, theoretical yield. So let's move on. Okay, the process gives 100% yield, Fe2O3. Let's take ratios of ore with iron. Okay, so 2 grams of iron, 2 moles of iron was given by 1 mole of iron ore. 2 moles of iron was given by 1 mole of iron ore. In order to have 1 mole of iron, you need to have half mole of iron ore. How many moles? Half mole. So this is basically asking how many grams of ore do you need. So in order to find that, you need to have the molar mass. What is the molar mass of iron ore? That is Fe2O3, 56 plus 56, because there are 2 iron. You may also write it as 56 multiplied by 2 plus oxygen 16 multiplied by 3. 56 twos are 112, 16 threes are 48. What will the answer come? 120, 120 plus 40, 160. So 160 is the molar mass of iron ore. Okay, applying the formula, mass in moles is equal to mass in gram divided by molar mass. You need to find the mass. Moles are half, 0.5 multiplied by 160. That gives you the answer 80 grams. That is your delta option. Once again delta, bro. Once again delta. We have got the correct answer as 80 grams of iron ore are needed to make your product, that is 56 grams of iron. Let's move on. Okay. So moving on towards our next MCQ, the average atomic mass of boron is 10.8. Again, an MCQ that's perfectly difficult for us, but good MCQ, you may say. So basically it is saying कि average atomic mass of boron is 10.8. Two isotopes हैं इसके 10 और 11 के नाम से. What is the percentage isotope of boron mass of 10? Now consider के the total molar mass of boron, the total boron is 100%. Of course the total boron will be 100%. There are two isotopes in which it is divided. If one isotope is 30% or 40%, the other isotope must be 60 or 70%. So basically this is the basic thing which we are going to utilize, the basic methodology in solving this MCQ. Let's suppose the mass of boron 10 is, let's say, X percentage. So boron 11 will have 100 minus X percentage of total boron. Why? Because if boron 10 is 90%, then boron 11 will be 10%. If boron 10 is 20%, then boron 11 will be 80%. How are we calculating it? Basically subtracting it from 100. 100 minus 20, 100 minus 10, 100 minus 90, whatsoever the value is. Now in order to find the average molar mass, that in our case is 10.8, we use the formula, that is percentage of one you may say boron, yeah, one isotope, multiply by its molar mass. What? Its molar mass. That in our case for X percentage we have taken 10, so X multiply by 10 plus the, again for the next isotope, what's the percentage for next isotope? It is 100 minus X. We will be multiplying it with, what's the molar mass? 11. So this is the basic formula which we are going to utilize for finding the average atomic mass. If we had 3 isotopes, अगर इस क्वेश्चन में 3 isotopes होते तो we will be extending the equation to the percentage of third isotope multiply by its molar mass, which is a complex MCQ once again. So 10.8 is equal to X multiplied by 10, 10X, plus 11 multiplied by 100, 1100, minus 11X. This is a bracket that is completely multiplying with 11. Okay. 10.8 is equal to 10x minus 11x minus x plus 1100. You must have thought by choosing pre-medical after 8th or 9th or 10th that now mathematics is gone. But here comes mathematics again. Here comes algebra again. What can we do? We can do nothing. So we have basically got 10 point, oh sorry, this is basically percentage. We are calculating it in percentage, right? So this will also come with a division of 100. So this is basically percentage. We have removed the symbol of percentage. That means percent by 100, percentage by 100. So 100 will come over here. 100 is dividing over here, so it will get multiplied over here. 1080 is equal to minus x plus 1100. Now 1080 is positive over here, it will go here and become negative, while minus x is negative over here, it will come over here and become positive. So x is equal to 1100 minus 1080, that is equal to 20%. So what's the percentage of boron 10? It's 20%. That's our delta option. Once again, delta, 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 and delta is coming to our right answers. I don't know why, but this is the case right over here. I hope you have understood the MCQ very clearly. If you have not, then repeat the video, pause, go back, rewind, and then listen again. Let's move on towards another MCQ. When 8 grams 4 moles of hydrogen reacts with 2 moles of oxygen, how many moles of water are formed? So basically, let's write down the equation 2H2 plus O2. Now I have memorized this equation by telling you again and again and again and again. So I basically memorized the equation with balancing. So when 8 grams 4 moles of hydrogen react with 2 moles of oxygen, how many moles of water will be formed? I think there is something fishy. There might be limiting reactant, there may be not. So basically we will be taking ratios from both the sides. If 2 moles of hydrogen gas react with 2 moles of water, then 1 mole of hydrogen will react to form 1 mole of water. How many moles are given? 4 moles of hydrogen are given. So 4 moles will be forming 4 moles of water. This is as per hydrogen. Now let's take ratio with respect to oxygen. Oxygen 2 moles of oxygen are given. In the equation 1 mole is forming 2 moles. So 2 moles of oxygen will be forming 4 moles of water. Basically 4 moles of water are being formed by hydrogen or by oxygen. If you can't understand these ratios, I have explained it very detailed in very detailed manner in my lectures of stoichiometry. Do watch them. This video will become too large and too lengthy if I will be explaining every single thing in detail. Please do watch that. That's a perfect video to understand stoichiometry for near me. So 4 and 4 moles are being formed. So where is 4? This is 4 beta option. That's really easy one from our part 1 of stoichiometry lectures. Let's move on. Hydrogen bonds in chlorine to produce hydrogen chloride. The ratio of masses of reactants in chemical reaction is, you basically have to find the mole ratios of molar masses. What is the molar mass of hydrogen? It is 2. What is the molar mass of chlorine? It is 71. 35.5 plus 35.5. You basically have to memorize the molar masses. We memorized iron today. We will be memorizing chlorine also. Okay, let's move on. Is there 2 ratio 71? 2 ratio 35.5? Wrong. 1 ratio 71? No, it's 2 ratio 71. 1 ratio 35.5, we can see 1 ratio 35.5 is the right answer. If we further simplify it, it is correct. 2 ratio 70? No, 2 ratio 71 to be very specific. 2 ratio 71, okay. 35.5 grams per mole is the right molar mass for each chlorine atom. So this is also wrong. Let's move on. A piece of diamond embedded in a golden ring. What is diamond? Diamond is basically carbon. Diamond, buckyball, these both are graphite. These three are the basically different forms of carbon. Diamond embedded in a gold ring with 6 grams. How many number of moles of carbon does it contain? You basically have to find number of moles. You have to find number of moles. What's the formula? Number of moles. Where is the cursor, bro? Number of moles is equal to mass in gram divided by molar mass. What is the mass in gram? The mass in gram is 6. What is the molar mass for carbon? 12. How many moles will be there? 6 ka table lagao. 1 by 2 moles are there for carbon. 0.5 moles. What's the answer? Now it's Charlie. Now delta. For God's sake, we are left with small amount of MCQs, but 0.5 moles was the answer, not delta this time. Thank goodness. A researcher has prepared a sample of 1 bromopropane. Okay, a researcher has prepared a sample of 1 bromopropane. Okay, let's just write it down. CH2, CH2, CH3. This is the basic structure of 1 bromopropane. This is the basic structure of 1 bromopropane. I hope you have learned it in your FSC. From 10 grams of 1 propanol, okay, CH3, CH2, CH2, OH. He has basically taken 10 grams of this. And for purification, he had made 12 grams of the product. Now, this is the actual yield. What is this actual yield? I already told you in my part 3 video that what is actual yield. Actual yield is basically the yield that is actually produced with experiments, and you cannot calculate it anyway with on paper, because on paper you are basically calculating theoretical yield or not experimental yield. Which of the following is the percentage yield? Okay, you have to find percentage yield. For percentage yield, you have to find theoretical yield. Let's solve for theoretical yield first. What's the molar mass of 1 propanol? Let's see. Where is the cursor? Carbon 12 plus 3. Okay, let's write it down. Let's write it down over here. 12 plus 3. Okay, let's count the carbon. 1, 2, 3. 3 carbons, 12 multiplied by 3. Plus, how many hydrogen? 3, 2, 5, 6, 7, 8. 8. Plus how many oxygen? 1, 16. 12 threes are 36. 8 plus 16, 24. What's the molar mass? It's about 60 grams per mole. 60 grams per mole. Okay, let's find out the moles. Moles is equal to mass in gram divided by molar mass. 10 by 60, which is equal to 1 by 6 moles. Okay. Now let's take the ratios. 1 propanol. Let's write propanol because it is an alcohol, of course. Ratio bromopropane, BP. 1 mole of propanol is forming 1 bromopropane. 1 mole of 1 bromopropane. Because it will be reacting with 1 HBr, hydrogen, and OH will be forming as a byproduct 1 water, and bromine will be replacing this one. If you want to have the full equation, complete overview. So 1 mole of 1 propanol is forming 1 bromopropane. So 1 by 6 moles will be forming, where is the cursor? 1 bromopropane. But the question is asking about mass in gram, not moles. The question is asking about mass in, oh, you may say theoretical yield. You have to basically find theoretical yield, not actual yield. You have to find theoretical yield. So in order to find that, these are the moles. You need to find molar mass, multiply moles with molar mass, and you will get the mass in gram thing. How? Moles is equal to mass in gram divided by molar mass. You need to find this molar mass and multiply it with moles in order to find the mass in gram that is actually produced of 1 bromopropane. Okay, let's find out the molar mass. For bromine, single bromine, it's 80. We have learned another molar mass. 80 for bromine. What? 80. Remember. 80 plus how many carbons? 1, 2, 3, 24. 36. We have calculated over here. How many hydrogen? 2, 4, 2, 4, 5, 6, 7 plus 7. 80 plus 36 plus 7. Okay, that's the perfect answer. This will give you the answer, that is 87 plus 36, 123. 123 grams per mole is the molar mass. Now multiply it with 1 by 6, 123. You can divide it with 3 first. 3 2s are 6. 3 4s are 12 and 41. 41 by 2 is the right answer. Let's consider this. Okay, 41 by 2. This is what? This is your theoretical yield. What is this? This is your theoretical yield. Now let's apply the formula that is over here in a small portion. That is percentage yield is equal to, let's change the color. Okay, let's change it to green. Let's say percentage yield is equal to that is actual yield divided by theoretical yield multiplied by 100. We have discussed it in our part 3 video. So percentage yield will be equal to what is actual yield, that is 12 grams. What is the theoretical yield, that is 41 by 2. Now this 2 is denominator of denominator, so it will move into the numerator, but in our next step. So it is equal to 24 divided by 41 multiplied by 100. Basically, if I consider this 41 to be 40, then my calculation will be easy. But remember one thing, I am basically decreasing the denominator. I'm basically decreasing the denominator. So my answer might differ from the actual value. Okay, let's see. Let's see. If I consider this to be 40, then I may apply a direct value, that is 2.5 right over here. 24 multiplied by 2.42.5 is 100. You can apply this calculation. 24 multiplied by 2, 48. 48 plus 12, that will give you the answer 60%. But remember, it's not exactly 60%. It will be a little smaller than 60. Why? Because the denominator was 41. I reduced it 40. If the denominator is reduced, the value becomes greater. Why? 1 by 2 and 1 by 4, which value is smaller? 1 by 4 is smaller. Why? Because the denominator is high. Basically what I did is made 1 by 4 1 by 2. In my case, a little denominator was made short, right? So I basically made the value a little higher. So it will not be 60 but 58. Where is the answer? So my answer is beta, that is 58. That's basically assumption. If you cannot assume, then you have to be perfect with calculations, which I don't think anybody is. So in some cases, in some questions, we have to make some assumptions in our video, in our questions. So that's all for today. I think that's the end of the slide. There are no more questions for in this mock test, but I hope you have got a crystal clear concept of every single MCQ that was taught in this lecture. Besides, we have a free of cost mock test every Sunday in our WhatsApp group. I will share my WhatsApp group link and my WhatsApp number in the description below. If you want any kind of video, any lecture, any problem walkthrough, I will be guiding you through every single MCQ if you want. Also, if you need any discussions, any guidance, any thing that is basically teasing you regarding MDCAT, you may discuss it freely from us. And that's all from my side. I think then that's a bye bye. Allah Hafiz.